Alright, we have finished all this. For this particular video, we will do questions 16 and 19 of your textbook 11.4 A Maths. Okay. Now, if you look at question 16, it is like an application question. Okay, we will start reading from here. The question is here. Okay, the rest are solutions. Okay, a rectangle is inscribed. Now, inscribed means that is totally inside the other shape. So it's inscribed in a semicircle. So you can see here is a semicircle, right? So this rectangle is totally inside this semicircle, and you are told that the radius of the semicircle is 1 unit. That means this is 1 unit. Okay? Now, what does it mean by 1 unit? How come they don't say 1 cm or 1 meter or whatever? Now, this you can think of it as at the x and the y axis, the coordinate scale. Like graph x and y axis. So we think of this as 1 unit on the coordinate axis. Okay, now explain clearly why the area of the rectangle is sine 2 theta square units. So they want you actually to show that the area of this rectangle is sine 2 theta. Now, how do you do that? Okay, we notice that this is given to us as x, this is y, and this is the center of the semicircle. Okay, which means that this rectangle also lies at the middle of this semicircle. So called, it fits snugly into this semicircle, meaning that this should be x, same as this x. Okay, now once you have understood that, you will know that the area of the rectangle is length times breadth, right, which is 2x times y. Okay, so once we can find what x is and what y is, we can get the area of the rectangle. Okay, and how do we do that? Now you can see that this y has to be perpendicular to this xy, because this is a rectangle. What? Okay, and this angle is theta. So if I want to find this, don't you agree that it's opposite and hypotenuse? So sine theta is opposite over hypotenuse, which means my y is sine theta. Okay, so I found this already. Alright, now let me try to find x now. X, right, adjacent hypotenuse. Okay, adjacent over hypotenuse. So my x is cos theta. Again, I sub this inside here. I will be able to get the area of the rectangle, which is 2 cos theta sine theta. So if you know and remember your double angle, 2 cos theta times sine theta, right, is sine 2 theta. Okay, so this is a sine 2 theta units square. Okay, so we have more or less shown it already. Okay, this is the working here. Alright, but this working is the same This working is the same. Okay, now this is part 1. This is part 1. Now how do you do part 2? They say hence find the exact minimum area of the unshaded region. Hence means you have to use this part A results. Okay, find the exact minimum area of the unshaded region. Now the unshaded region is actually the semicircle minus the rectangle, the area of the rectangle. Am I right? Okay, so maybe I just use this this, because I ran out of space, I use this diagram. Okay, so don't you agree that the area of this semicircle is half pi r square? And because the r is 1, right? So you sub 1 here, that is your half, this is your pi, and this is your 1 square. You will get pi over 2. That means the area of this semicircle is pi over 2. Now, if I want to find the unshaded part, don't you agree it is the semicircle minus away the rectangle? Okay, so this is the area of the unshaded region that they're talking about here. Now, how do you find the minimum area? Now, they are assuming that the angle theta here can change. That means this theta can become bigger, can become smaller, and then this whole shape will change accordingly. Okay, we know that this is the important part here. Sine theta, right? Sine is between -1 and 1, correct? See, quarter of an egg, quarter of an egg, quarter of an egg, quarter of an egg, right? Okay, so don't you agree that this is 1 and this is -1 for y equals to sine 2 theta? Okay, we don't look at the minus. So the minimum value of this, right, must be pi over 2 minus 1. Okay, so that's your answer already. Alright, this is the minimum value. Okay, so that's all for this particular question. Now we'll do one last question for today. This question is slightly complicated. Actually, it's very complicated. You are supposed to prove the identity. Identity is just like an equation that's always true. That means whatever x value that I sub in, the left hand side. Okay, by the way, this is the left hand side. Okay, the right hand side is very complicated. Is this one? Okay, so you are supposed to prove this identity. Now, I check with you. Do you think you can start with the left hand side? Or should you start with the right hand side? Definitely, you have to start with the right hand side. Because you see the left hand side, right, it's just this, From such a simple looking thing, right, how are you going to manipulate until it becomes so complicated? Cannot, right? So you have to always start with the more complicated one. This is the more complicated expression. Okay, so you start from here. Now, how do you start? Actually, can you see that this part here is actually your difference of cubes? I don't know whether you still remember. A cube minus b cube. Remember? So what is this a cube minus b cube? The answer equals to, see, this one follow, right? Then square this, then in between, if this is plus, then this is minus. If this is minus, then this is plus. Okay, so this part here, later you can actually use this difference of cubes. Okay, so that's a good revision. Okay, now you notice that the right hand side consists of this plus this, something plus something. But what you want to prove, right, is only one single fraction. Okay, so the immediate logical thing that you must do is to make the two denominators the same so that you can more or less become one single fraction. Alright, so that's what, okay, this one is just copying the question. That's what we are doing here. Can you see that? I multiply by sine x plus cos x, sine x plus cos x, so that the denominator, right, are both the same. And then you can work out, you can expand the numerator, and once you have written this, okay, take note, they ran out of space, right? So this thing is this thing, and this, let me use a different color. This part here which just now I told you is the difference of cubes, right? Is this whole thing. Can you see that? Where your A is sine x, your B is cosine x. So A square is sine square, B square is cos square. Then this is your AB. Huh? So this whole thing is at the numerator, okay? Numerator. Alright, okay, then after this, what do you do? After this, can you see that? Okay, now is the other thing. Can you see that sine square x plus cos square x is actually 1? So this is what you get. This part is this part here. Okay, can see that? Alright, okay, then this fella, I put curly thing, okay? And this fella is like A minus B, A plus B, right? So it becomes A square minus B square. So this whole thing, this times this, right? Because this whole thing is multiplied by this, has become this. And the 2 is just a 2 here. Okay? And the cosine 2x, just cosine 2x here. So far so good. Okay? And then you see, okay, let me bring the double angle formula down. Okay, here, right? Can you see that sine square minus cosine square? This is cosine square minus sine square. It's like everything is the same. Here, I'm talking about here. It's like everything is the same except minus plus. Minus plus, right? Okay, so this is actually minus. This is actually minus cos 2x. Then when you take minus cos 2x times 2, you get minus 2 cos 2x, right? So this is the part here. And this, what is going on here? I make this the subject. Okay, when I make this a subject is sine, here. Sine 2x divided by 2. Okay? Yeah, so this is where it came from. Then you ask me, why you want to do this? Because ultimately we want the argument, which is the angle inside, to be 2x. That's why I'm changing all these to double angle. Changing all this to double angle. This is already double angle, so I leave it. Okay? Now, see what happens now, okay? I can now expand this. Open up the brackets. And I'll end up with this minus this. And then plus this. And notice that there's one of this here. And there is minus 2 of this here. I can combine it to become this. It's like 1 minus 2, so it's minus 1. This remains unchanged. Okay? Now, what do you do after this? Can you see that we have a common factor here, cos 2x? I take it out. In fact, I take out minus cos 2x. I take out a minus. So this will be 1 plus sine 2x. Okay, and now the denominator, I can a plus b square, right? So I square this times 2. So I get this. Okay, now can you see again that this plus this is 1? Remember your sine square x plus cos square x equals to 1. So I can write this as 1. And very nicely, they cancel out to give me this. Okay? Now, isn't this? This minus is still this minus, right? But this cos 2x, cos 2x, right? I can write it as 1 over secant. Why? Because secant is cos, is 1 over cos 2x. So 1 over this is actually you flip to get this. Okay? So this is actually the same as this. Proven already. Okay? So that's all.